So coming back to why we require, uh, we say that Autodesk will be the, very strong thing to use in the highway projects. So it has many advantages in the highway engineering project as well. As one I said, because once the client changes something in his mind, so we need to update as quickly as possible, so that instead of doing the whole process from the start, it has in as it interconnected, we change the basic features, the other parameters will be automatically updated. So apart from that one, it has a lot of other features, like it supports different BIM infrastructure applications, like it has this Autodesk background. Autodesk is a firm which is developed the AutoCAD Civil 3D. So Autodesk has many other application, infrastructure application. For example, of InfraWorks, it may be of Navisworks, or maybe Rivet, which does the 3D visualization, 3D comparison for the BIM project, like building information model project, where we combine all the highway engineering project into one category and will submit it. So that parameters also will be developed by the Autodesk, which supports the AutoCAD Civil 3D. So it becomes a very important player to give all the combined application in one single platform. So that's the biggest advantage why we use AutoCAD Civil 3D. So I'll just read through the other important scenarios, or the important things why we require these applications. So it will have the design structure more efficiently. The transition from 2D to 3D is very smooth and very easy, user friendly as well. Checks design against standards, as I was mentioning. We can just feed the application to the application the design standards, and it will take care. It optimizes designs, evaluates feasibility and its impact, integrates different other Autodesk software, as I was mentioning. We have like automation documents, and we have can report generation made very easy, and we can customize the report generation as well. How the horizontal alignment report or the vertical alignment report, we can just optimize, and we can take whatever the required reports we can, and it minimizes error and rework. So it compares in the 3D as well as in the 2D, so that we can visually see where we are standing in the design, and it optimizes our work much more easier. So here also there are lists of parameters where we can use. As I was saying, the documentations to delivery standards will be made smoother, and we can configure, customize. Those are the parameters we can make it. Deliver 3D models to different machines directly. So once we do this one, we can just give it to the surveyor or the contractor. We can just use those 3D parameters for his automated machines for the construction of the road. So that also we can do it very smoothly here. Apart from that, there are multiple softwares which do the highway designs. We can just have the export from that software, and you can build this into this civil 3D applications in response to project changes, because all the features are interconnected. We can run through the process very quickly. uh, Again, the design changes automatically, it updates, provides better estimation of materials and dynamic calculation. Those analysis also we can make it. Shares and update the model in real time, because nowadays the client are expecting all the models to be uploaded in their cloud ways. We just work directly in the cloud, so that whatever changes we make here will be uploaded and checked by the clients directly, without any submission separately. Only through emails we can just communicate that when I updated the model, please have a look, so that the client sees in this cloud, so the design updates and also those are the multi advantageous things where we can achieve using these applications. So next, I will try to show the workflow of Civil 3D applications. The standard template, it's not compulsory to follow this process, because around 80% of the time we will follow this process only, because of course every project is unique, every project is different. So we need to take the project within their priority, and we need to give the input to the Civil 3D, and we need to design. But overall, there will be a standard procedure we need to follow. So that process will be I'll be explaining in this following slides. So AutoCAD Civil 3D workflow basically. So what I try to say is AutoCAD Civil 3D features a range of design and analysis of objects within the three-dimensional dynamic engineering model. So it gives an option for a designer or analyzer to make his decision of how to go about a road project in a standard manner, so that it can give the best design, safe design to the end user. So basic workflow will be whatever the survey data we carry, we need for the design of the highway projects will be collected first. So that may include points, lines, surface, or alignments, or even the corridor directly. So that can be imported first, and we try to do the design accordingly. So all the objects of the Civil 3D have a hierarchy that can be viewed in the interface component called the tool space. As I was explaining in the overview slide, all will be controlled in the civil tool space command, for starting from the survey, alignment, corridor, and the report generation. So once we familiarize with that, so next parameter, which is we need to do it in the prior before we are going into the further steps, will be the label styles and edit label styles, which is very important. It decides how the the cross section looks, or how the DTM or the road surface looks, or how the alignment looks, or how the corridor super elevation looks, or visibility looks, or the final output, like drawing looks. So all these are controlled by the label styles, so that we need to prepare first. Many of the times what we do is each consultant, for example, will be having his own set of style sets, what they use as a standard things. So they will create it separately, and we will use this for all the projects. So we need to create it first. That can be controlled using this setting commands. In the tool space, again, we go to the settings, and you have all the features you can see in this slide. For example, I have shown for the alignment, there are like alignment style, design checks, label, table, and commands. So all these features can be controlled visually. How we need to do, for example, if you take an alignment, you need straight in one color, curve in one color, that we can control using this label styles. Or I need the chain edge interval at 10 meters, I need to show that 0, 10, 20, 30, that increment I need to show, I can control here in style set. So the color, the text, the other symbols, all those parameters we need to prior fix before jumping into the design, because it gives a visual impact and visual easiness to the client at the end point. Because if we use the uh, default setting of the Autodesk, it looks very dull, and the design doesn't looks a proper standard for that. So for that one, we need to do this changes of style set first, and we need to go for the further modification or the improvement in the Civil 3D. So once we done that, so we have all the survey data, we did all the style set. What is the next step? Next step is importing the survey data into our design file. So there are multiple ways, multiple kind of importing the data to the Civil 3D. Here in the bottom, you can see there is an insert tab which says all the different variables where we can use for importing the survey data. Here in the list, I have mentioned some typical basic scenarios or basic data what we use. We use CSV files. CSV files is nothing but comma separated values. It's an Excel file, Excel format basically, where the surveyor has feeded the coordinates of the site data in the XYZ format, eastern, northern, and the elevation coordinates. So that data we can use, or sometimes the surveyor gives you the AutoCAD file. That file has points, which is 3D, like it has three-dimensional points, like in the previous slides which you see. For example, this one, these are the points, we can use it directly, and these lines are called as break lines, which we can use to generate the DTM or the triangulation, what we call in the technical term, that we can use it to create a DTM or the survey surface. So other format will be the land XL format. This will be the one important export format of Civil 3D, where we export survey data from the other design or the other team. We can just take that their design or their data directly into our Civil 3D applications. So for all the parameters what we shown in the prospector tab surveys, you can see here these are the scenarios where we can import all these parameters. And if you just right click in this portion, there is an option called export to land XML. So you can export a particular survey what you have created for that region, or particular alignment or particular corridor, or we can just export in land XML, and we can just use this features in other drawings as well, other designer or other client, whatever it is, we can just transfer in the data. So that's one import method. So other will be the Genio. Genio is nothing but the other applications in export system. So that also we can upload it by using the separate toolbars where we need to do the add-ins. So add-ins is nothing but extra feature in the Civil 3D where we can add other applications to the Civil 3D. For example, if you are adding a vehicle tracking system, it's a separate software developed by the Autodesk. So that gives you the path of the vehicles, how it goes in the junctions or a curve exactly. So that separately we can install using the add-ins, and we can do the designs. So not only in application Civil 3D application, we have the flexible thing of parameters what the Civil 3D has. We can it's not like we stick into that parameters only. We can just add extra applications into it, and we can work through it. Like for example, if you are designing a road marking or road signs, there is separate applications where we can install that one for different countries standards. Different road markings will be there, so that we can install it separately. It gives you the accurate analysis and design for road markings. Those are the parameters. Flexibility will be there in Civil 3D applications. So that I would like to try to share at this point of time. So the other options is from the CAD drawing directly we can just import the survey data here, because of course this is a CAD platform. It runs in the backend of the backend will be the AutoCAD only, so that we can take care in this design. So moving forward quickly, so these are the process I would like to share, like CSV point import or the drawings object import. What are the steps we need to follow in this one? So this is the procedure what we follow. So again, it will be how we import the survey data, the steps I just try to share here, how we can create the surface over here. So once the surface is done, we just quickly move on to the horizontal alignment. As I was showing in this one, the central portion which gives the all the details about the alignment. So if you click the alignment, it gives a drop down over here. It has many options of creating the alignment. So what we need to know is it's just connecting those two lines straight or a curve in a different manner. So all this option can be explored or used in this toolbar to create an alignment here. Here you can see the in the image, you can see all these parameters, that these values, how these values are displayed. Again, coming back to the style set, I have created particular style set which says we need to give that the chainage markings for every 20 meters like this. So it takes our style set for this one and it displays that one. So that's how we can just show up this style set in this horizontal alignment as well. So coming back to this one alignment, so these are the property toolbar or the commands we can use for creating the horizontal alignment. I'm not going into detail of how we do that, but I just wanted to say to you this is the way or where we can find the horizontal alignment panel. Similarly for vertical also the same thing goes up. In just below the horizontal alignment, you have the option called profile. Once we click this one, it has many options here to create a profile and to create a profile view. This is called the profile view. Once the profile view is created, we use the same tools as in horizontal, but in a different way, to create a profile along the existing ground, or the existing features what we have. uh, so that can be controlled all in this parameter. So visually what we are seeing here are all controlled by the style sets. So those two parameters we need to take care while designing the vertical features as well. So it's very user friendly, very direct to approach. So only basic we need to know is what are the scenarios, or what are the standards we need to use, like what are the grades, minimum grades, maximum grades, sag, hog curve, k values. Those parameters, if you know, we can directly chip into this one, which gives all the instructions in the user friendly manner. So very easy to use. So next, once we do done with the vertical, we will directly chip onto the corridor model. Here in this slide, in the smaller portion, I just circled it, which says the corridor options. Once you click that corridor options, it gives so many features to check with the develop a corridor section. Corridor is nothing but the cross section what we need to develop in this section. So how we decide the corridor, which corridor we need to decide, that has to be done in the assembly sections here. So assembly section, once you click this one, this is the assembly developed for the particular project, where this point will be the center point of the road. Then a lane we need to create. All those lanes, how we create that one, again we need to go back to this palettes, what we call. At the moment, unfortunately, I don't have that tab actually. So we call it as palettes, which will be here, exactly this point. If you check this one, it gives different options of carriageways, different options of lanes, different options of shoulder, or the width, verge width and all. So, or the embankment, or the barriers, or the footways, or the curb. So all this, assemblies will be there. We will join together that assembly, sub assembly, and we create an assembly over here. In this Civil 3D language, we call it as assembly and sub assembly. Assembly will be this whole part. Subassembly will be the each parameters, like lane, or a curb, or a lane, or a embankment, whatever it is. So those are all like subassemblies. So we will join it together to form a assembly. That assembly we need to run through this corridor for that particular alignment, particular profile, particular ground. So once we do that, it creates a corridor for us, which gives you the cross-sectional thing in our design. So that's how the process will be there. It's a simple process to be followed, very easy to use, and very user friendly, I would like to say. So next I would like to say about the super elevation. Super elevation, of course, will be one important factors for designing of any corridor model, corridor or cross sections. So Civil 3D has a separate tab for super elevation. Here you can see. So once you develop the corridor, if you click the corridor, again it gives some more options in the ribbon bar for our analysis and change editing purpose. So we can just edit the corridors in million ways. So in that option also, we have the option called super elevation. So super elevation we can just control here, depending upon the carriageway, the chainage we can feed in this one, and the different kinds of lanes are there in this one. The like 4-5 lanes are there. For each lane you can just place the values of percentage directly, like this, as you shown here in the image. Each lane has different percentage for different sections. So calculation has to be done, and we can just place those values, and that value has been used for the export purpose. So those are the basic things we can do, but it is very flexible. I would like, that's the message I would like to say in this thing. We can just easily feed these values and do the super elevation analysis and design very quickly. So next, coming on to the Civil 3D visibility thing, which is like maybe in a junction, or maybe in a vertical curve or horizontal curve, we need to do the visibility. So for that one also, depending upon the standards what we use, we can use this item in the analysis and do the visibility parameters as well. So coming back to the volume calculations, so again in the analysis tab, you can have the dashboard for the volume calculations. So it is of course it is a user friendly. It gives a basic uh, about details. It asks basic details like about the ground, about our design ground. So both we can just compare all together and put into a sheet of informations, and we can just get the quantities very easily. So we can just do it like section wise, or as a whole project area. We can do like multiple options are very flexible, very user friendly. We can just do this one. So finally, the report generation will be there. So again, as I said, in the tool space, in the toolbox, we have this option called report generation. As you can see in this one, there are multiple options for report generation. We can just give it for horizontal curve separately, design criteria, what we use, all those parameters, setting out, or the stations, all these design parameters, we can take it out from the civil 3D applications. Very neatly presented one. We can just customize also in the process however we want. We can just export it into the PDF or export into the Excel format for further calculation, further analysis. All those parameters we can do in this report generation. So this will be the final drawing outlet. This is the example I would like to say. So each consultant firm or the uh, client firm has a different set of drawing output format. So in this case, I would like to typically show what will be the plan and profile output. We just developed this one in the AutoCAD. So you may have been, if you are using the AutoCAD, you may know the feature called XREF. Calling up different drawing using the command XREF, external reference. So using that one, we just develop these cross sections or the plan and profile drawings for the final outputs. In the right hand side, you can see here, you can give any legend or a key or any notes we can give it, or these parameters will be stages of drawings, different stages, or the client name or a consultant name. And those are the basic like a project name or a drawing number, the scale. Those are the parameters we can just finalize here and set a sheet output. That output can be used directly using the XREF. So those are the advantage we have in civil 3D thing. So again, coming back to the style setup, what I was saying, Excel, this is again the process what we follow, like overall label editing, surface label editing, alignment label editing, how the things we can just update it. So the other features like I would like to show here is a couple of other features like grading and pipe use network. Grading is nothing but if you want to have the constant slope between two different elevations or between two different surface, we can use those option called gradings. Pipe network is a three-dimensional thing where we can use for development of the underground sewer network or water network, or the OFC cable network. So all those options we can just additionally do in this one. Apart from that, we have the rail design as well in this civil 3D, that also advantageous for these applications. So that being said and done, that is the basic process what we follow in this civil 3D workflow. So similarly, we used one such template to create model intersection design for our case study. So I'll be going through briefly about this project. So basically what we followed is these steps what I said, like the template, like importing the data, creating the surface, creating the alignments, corridors, modeling it, doing the super elevation, doing the visibility check, and finally the report generation and the drawing outputs. So those are the basic procedures to be followed. Yeah. So brief about this project will be, so you can see this a roundabout, you can say that it will be an intersection roundabout. Intersection comes the roundabout, which will be developed into the grade separator interchange because of the increase in traffic and then future development. Because of the analysis and planning, we have concluded that it requires grade separated road because without with the traffic signal, we can't control this huge amount of traffic. It will create a uh, traffic more traffic timings. So for to avoid that one, to we use the grade separated interchange, and we did the analysis and design for this one. This is one particular junction in from that site. We just took it for our development purpose, and all the points and the text what you see are the existing survey data we received from the survey team here. So that has been plotted into the AutoCAD drawing directly. So we use this data. It will be all the data, and data will be in 3D format. Maybe it's a 3D lines, or maybe it's a point, or the text. All will be in the 3Ds. It has the elevation at this point. So we use that data for our design as well as modeling purpose. So first format will be development of the existing ground scenario. So all the data what we have, we developed in civil 3D applications. We called all the points, call all the lines, and in the text as well. In some places we require that. So all these parameters are used it to create a existing ground surface. We need the base first. So the base will be existing ground surface. So we need to analyze the scenario first, how it will be in the how the grounds will look like, to further do our design of alignments in interchanges and all. So that we have created first in the first place using the civil 3D applications. So this is a project site basically taken from the street Google map, as well as the satellite image. So you can see a junction here, which will be sorry. I'm sorry. Yeah, which will be developed into the interchange. So this has been developed into an interchange. Here you can see this is a 2D plan what you see here, but in 3D reality, the roads, you can see this is the main carriageway, dual carriageway, which is passing through the road directly. So these are the connecting elevated interchange, which is grade separated, which is going above or below the main carriageway. So that development has been done using these applications for this interchange design, using the parameters what I was mentioning in the earlier workflow of civil 3D. So basically what we did is we had the existing ground, and we designed the alignment using all these features, and the vertical profile depending upon the interchange standards what we need to give. That depended on the carriageway as well as the design standard of that particular area. We did that, and we developed the corridor model using the assemblies, sub-assemblies, assemblies, features of civil 3D. So that has been uploaded into this design. So finally we clubbed all these parameters, and we created a contour map for this particular junction, using all these parameters in civil 3D only. So the final DTM generation for the proposed one also we need to provide. So whatever we will be constructing, whatever we design, that also will be surfaced in this model. So this is the horizontal, what I was trying to say, how we are developed these horizontal parameters. So these are the basic idea. All the features used, we use civil 3D only for this one. So the approach may be different for different project, but the concept will be remaining the same for the highway projects. So the vertical alignment design what we're trying to show, and this is the cross section corridor modeling. This is the assembly point what we are trying to show. This is the cross sections what we are trying to show here. And finally this is just a section of that project where we try to develop the model of junction here. So this is the corridor model analysis we did for different regions. We had different assembly we need to provide that, so that all we can control here. So these are in-depth knowledge. Once we start using this application, it will be very familiar, these words and all, like frequency target, horizontal vertical things, assemblies, baselines, frequencies, all those standard words we can just go through it once we start using these applications. So finally, what we try to show here will be the design counter plan, report generation, drawing output. These are three parameters mainly the client asks at the end of the project. So for that one, it's we need to try to keep it simple as possible for the clients, so that it should not be complex thing for anybody to use at the end point. So what we give will be the minimum and the basic, but it has all the data into it. That's what we need to aim at the end. So we not do it in a very complex manner. Um, Complex should be there in the design, but at the end of the thing, we need to give it as simple as possible. But for that one, we just give these three details. So the counter plans which is so here, it gives all the details of how smooth the junction design is, how it will be used it. The drawing gives you the horizontal vertical cross section parameters to the client. The report again gives the how the horizontal values are being used, vertical values are being used, super elevation values are being used. Those are the parameters we can just give. And in the left image you can see the basic design what we did, and the right image is nothing but survey data superimposed. Whatever the junction data in the survey will be kept as it is, and what the green one are the proposed one. We just clubbed it together and try to show it in a different way. These are the basic thing we can develop in the civil 3D, but the client expects in a different manner, like he wants to see the 3D view of the roads, how it looks like after the construction beforehand. So each and every details, like even from road marking to the traffic light to the street light to the the gardening portions, those are the parameter, those are the the ultimate visualization we can develop using the InfraWorks or the Navisworks, those kind of application, which is of course the AutoCAD's uh, other applications. So that applications we can use this data directly. So this is one big advantage of having the design in civil 3D. You can just pull this data, as I was saying, the land XML. We can just create the land XML of these contours, and we can just send it to the InfraWorks directly. So import the land XMLs in that InfraWorks and add those all the features. The base we have from the civil 3D and all the other parameters we can just give it in the InfraWorks applications. So that big advantage we can have in this civil 3D application by doing the design using the civil 3D application. Yeah, finally, the report generation will be set as I was showing in the earlier set. We can just create the report generation easily in this civil 3D applications. So next comes the last part, which will be the installation process. We can just go to the Autodesk website. It gives all the details about how to download it, how to install it, and how much we need to pay for the applications to use this one. So we can just easily download and install in this version. But it has a Mac version as well as the Windows version, so we can just, depending upon the type of OS you're using, you can just do that parameters as well. So to sum it up, so AutoCAD is a very vibrant and a very important application. We can use it for the highway engineering field especially. So huge advantage will be there uh, in the using this application, I would say. At the end, anybody can learn this software with basic knowledge of highway engineering, those horizontal features, those what I was mentioning in the codes. If you know that language, using this application is very easy, because nowadays, like technology is improved. We have, like video platform website like YouTube and all. If you just go and Google what you want from the civil 3D, it appears instantly, and it gives a brief idea about how we can use it easily with the basic ideas. So that we can just do it in this from these applications. And also having the different skill set using is another factor. So as I was saying, it's a very popular application to be used at this point, so we can use it very easily. So at the end, I would like to say we can conclude that the knowledge about this particular software helps in the job market as well, because it's a happening software in this highway engineering, consulting firms. Everyone uses these applications, and the client wants the data from these applications in all over the region, like in India, Middle East, or in US or UK. So all these clients who are up to into the road engineering wants this output from this application majority. So It's a very important skill set to have for any graduate persons, or the starting persons who are into the field of highway engineering, or you can say the rail engineering also. It's a very important thing, so that we can use it. So that's about this application and the basic about the highway engineering. So thank you very much for giving this opportunity, and thanks all for your time